20 gram ball is fired horizontally with a speed v0 toward the 100 gram ball hanging motionless from a 1 meter long string. The balls undergo a head-on, perfectly elastic collision, after which the 100 gram ball swings out to a maximum angle of 50 degrees. What is velocity initial?
Okay. So they collide. And this ball will probably go that way. This one swings out. So how would you measure the angle that it swings to?
L minus L cosine of theta. L being the length of the string.
Right, and your theta is just right in here, so 50 degrees.
So for the first part, it's energy, right?
Yep.
And then for the second part, isn't there 3 parts?
Well, it's all kind of energy,
Okay.
which is nice. But what do you have to do in order to get V0? So V0 is your first part,
Mm-hmm.
and that's what you're trying to solve for.
Right. Well, we're going to have to plug it into kinematics. No?
No.
We're gonna have to use.
Fortunately not.
We're gonna have to use momentum.
Yeah, momentum is a part of it, but do you remember, so perfectly elastic collisions?
Okay.
Whenever you see that something has a perfectly elastic collision, those are the equations you want to look to.
Okay. So perfectly elastic, V final is equal to M1 minus M2 divided by M1 plus M2.
That's V final of 1, right?
Yes. Times V initial.
Of 1.
And V final 2 is equal to 2 M1 divided by M1 plus M2 V initial X. But times 1.
Yeah. It was also 1.
Okay. So, is that it? We need to find velocity initial in the x direction in order to solve for velocity final. But can't we just switch the 2?
What do you mean switch the 2?
Can't we, do we have to solve? Never mind.
So there's kind of 3 steps, right? You have, this ball starts out with the initial velocity, it hits this one, and after that collision, immediately after that collision, so this is actually the end. That's in the end what happens. But immediately after the collision, you have this little ball bouncing off, and this one has some velocity.
Mm-hmm.
So the first part, you have a perfectly elastic collision, which causes some velocity in this ball, which we then do energy to find out how much velocity it originally had. Okay.
Okay, let's do it.
So if we wanted to, in order to have this, well, what's the energy equation for after the collision until it stops?
Well, after the collision, they both will have potential and they will both have kinetic.
So right after the collision, let's put our datum right through the center of mass of both of them.
Okay.
So that way we don't have to worry about potential energy initially.
So they're both being 0.
Mm-hmm. So initially, let's just, are we too worried about what happens to this ball after it leaves?
No.
Because we don't know where it goes. We don't know anything more about it. The only one we know about is this one. Okay? So it starts out with just kinetic energy. Right? It's knocked and it starts to swing up. Then what happens after it starts swinging upward?
It gains potential energy.
Right.
So that means that we would have both kinetic and potential on the other side.
Well, as it's swinging, right?
Right.
But what's significant about this angle, 50 degrees?
That's as high as it will go.
Mm-hmm. So it starts out with this speed, it swings out, and it gets to 50 degrees and it stops. So what's our energy right then?
0.
The kinetic energy will be.
Okay.
So it converts from kinetic at the bottom to all potential when it reaches that height. Does that make sense?
Yes.
So it just equals mgh. So that's the energy half of it.
Okay.
Can we solve that equation?
Yes. No. We can solve it for velocity.
Right. Because we know our mass, and it's going to cancel anyway. And we know gravity, and like you said, the height will be L minus L cosine theta.
So it goes V equals 2G H L minus L cosine theta. Is equal to our velocity, or the square root of that.
Right. And H is L cosine, or L minus L cosine theta, right?
Right.
Yeah.
That's a velocity initial at what point?
For this ball, right here, right after it got hit, that's its velocity as it starts to go up.
Okay. Makes sense. Now we take that velocity initial right as it's hit and do what?
So this is the speed it had right after it was hit, right? So what? Initially it was just at rest, and it was hit by the other ball, and then it was
So
given some.
we can plug it into M1 minus M2.
That'll give you your final velocity. So this would be, with these equations, ball 1 is the one that's moving, and ball 2 is the one that's at rest. So which final velocity did we just find?
You found ball 1's final velocity.
So this one's ball 1,
Mhm.
and it went this way. We found this velocity, right?
Why? I thought you said this one stays still.
Oh, so ball 1 is the one initially that's moving, and ball 2 is the one that's sitting still. So that for these equations, you use this one to find the final velocity, the one that was already moving to begin with. So in these equations, whenever you use them in a perfectly elastic collision, ball 1, so V final 1 would be for this ball.
Right, exactly.
So if you want to find what happens to this ball after, you use this equation. So this velocity right here would be this equation. And then for ball 2 was the one that was originally at rest, that would be this equation. Okay?
Okay.
And we solved for this velocity using energy. So originally, what happens here, is originally the ball on the string was just sitting at rest. It got hit by the other one. That gave it an initial velocity, which swung it up until it stopped. And so we can track that back. We use the potential energy to figure out how much kinetic energy it had. That will tell us the velocity after it was hit, which we can use this equation to solve for, right? So we can put this in here. So we have square root of 2gl minus L cosine of theta equals 2m1 over m1 plus m2 times, what should we call the initial of 1?
Why does it have to be anything but the initial one?
Well, I guess the answer you're looking for, they use the notation
B
B
naught.
naught. So that's what we're looking for, right?
Mm-hmm. And so we know everything else, so it would just be, we can just go square root of 2g L minus L cosine of theta divided by 2m1 divided by m1 plus m2.
Yep. And then you kind of invert that, I guess. You just multiply the reciprocal. It'll have m1 plus m2 over 2m1 times the square root of that. That's your velocity.
Yeah.
So we knew that this velocity that we were looking for was going to be what caused the velocity in this ball, which would eventually turn into potential energy. So we could solve for the potential energy,
Okay.
to find the kinetic energy,
Okay.
to find the final velocity of our second ball,
Okay.
which we used to find the initial velocity.
The first ball.
Mhm.
Okay. So we solved for kinetic energy and potential energy
Mhm.
to find our velocity final of the one that was originally at rest but is now moving.
Right.
We take that, plug it into the equation
Mhm.
for the one that we're given, and then we solve for the velocity initial the other. That's cool. That makes sense. Thank you.